Hi everyone, this is the 12th video of the ACT Math Practice Problem series, and here we have one interesting problem from the Laws of Exponents. As I always recommend, before seeing the solution, you can pause the video and give it a try yourself, and after that of course you want to match with my solution. So let's get started. So here we have this expression which is p to the power a over p to the power b whole power a plus b. That means this each of the components, they have their one power also. So inside the parenthesis, the first term has p to the power a over p to the power b, then whole power a plus b, and then in the second factor we have p to the power b over p to the power c whole power b plus c, and in the third factor we have p to the power c over p to the power a whole power c plus a, and we have to simplify it and we have to find what it simplifies to. So it will be p to the power something, and if you look at our answer choices, we have various answers there and it's very difficult to eliminate any of these answer choices. So let's just try to solve it directly. So now in each of the parentheses, can we write it like this? So we can say that inside the first parenthesis we have actually p to the power a minus b, and then outside of course we have the whole power a plus b. And why I wrote it like this? Because we know the property of exponent which is like this: if we have a to the power m divided by a to the power n, that becomes a to the power m minus n, and that's the property that I have used here. Where we had p to the power a over p to the power b, I have written that as p to the power a minus b. And then similarly for the second term we can write it as p to the power b minus c, and then we have a whole power b plus c. And for the third term also we can do the similar thing. We can say okay, this must be p to the power c minus a, and then of course whole power c plus a. Now from here let's try to eliminate the big parenthesis here. So we can say okay, the first factor must be p to the power a minus b times a plus b, because we know this property of exponent that says if I have a to the power m whole to the power n, then we can write it as a to the power m times n, and I'm going to use the same property of exponent to simplify this expression here. So the first factor will become p to the power a minus b that we already have inside the big parenthesis, so p to the power a minus b, and then times a plus b which is outside the parenthesis, and then times the second factor. The second factor again can be written similarly as p to the power b minus c times b plus c, and also the third factor can be written as p to the power c minus a times c plus a. And then if you look at each of the factors, the first factor is now looking like p to the power a squared minus b squared, because we know that a plus b times a minus b is equal to a squared minus b squared. That's an algebraic identity. So I'm going to now combine each of these powers here. So the first one will be p to the power a squared minus b squared times the second factor will become p to the power b squared minus c squared, because b minus c times b plus c gives us b squared minus c squared, and similarly the third factor will become c squared minus a squared. And now it looks like we have three factors where the base is same, so we can combine them with the same base. So we can write it as okay, so this must be p to the power. Now we are going to add the exponents there, because you know from the property of exponent that if we have a to the power x times a to the power y times a to the power z, that becomes a to the power x plus y plus z. So we can simply add the exponents. So similarly here we can say okay, so this must be p to the power a square minus b square plus b square minus c square plus c square minus a square, right? And then from here, as you can see, if we remove the parenthesis in the exponent there, then this is going to now look like, so this is going to look like p to the power, I'm now removing all the parenthesis in the exponent, so this will be a squared minus b squared plus b squared minus c squared plus c squared minus a squared. And the interesting thing here is that you see this positive a squared and this negative a squared, they will cancel out each other. Similarly negative b squared and the positive b squared, they will cancel each other, and negative c squared, positive c squared, they will also cancel each other. So we are going to be left with p to the power 0. There is actually nothing in the exponent anymore, so it becomes 0, right? So now our exponent is 0, so this is p to the power 0, and of course this is equal to 1. We know that any non non-zero real number with a power 0 or exponent 0 gives us a value of 1. So here if you look at our answer choices, the correct answer choice would be option number K, because that is where we have p to the power 0 right here. So this should be our correct answer choice. And in fact, you know, in the exam you could be given as a value of 1 instead of p to the power 0. So you have to be careful whether you are given the 1 or p to the power 0. You have to understand that they both are the same thing. I hope everything made sense. Thank you for watching. See you in the next video.